Going live. We are live. Hi, Ioana and Flaviu. Welcome to Venture with Grace.
Hi, Grace. Nice to be here.
Yes, thank you for having us.
To start the show, I wanna maybe at the beginning I wanna give a huge shout out to Mark from Comcast Ventures. He's awesome that he have introduced me to you guys, and maybe we could start with the early stage of your career. So before this company, I think Flavio was a multi-time founder, and then you guys both work on the gaming side before. So I guess maybe we could talk about what were some interesting insights that you've learned early on in your career, kind of shape you into who you are today.
Sure. Ioana, do you want to take this story?
I can talk about how we met, but I think kind of it'd be good for people to because you started a few businesses before, so I think it'd be great to hear about that. But basically, we met 16 years ago. We were working for we're Romanian, so we were working in Romania at the time. Flaviu's, I think, third company was acquired by a large global U.S. infrastructure provider. This was before AWS and Google Cloud were a thing, by the way. So it was like when people had dedicated servers and web hosting and so on.
Mhm.
So we were an R&D office building cloud products, and some of the first cloud products, really. And I joined to kind of run the product part, um, and we together kind of developed this this kind of new cloud prototype. So at the time, after doing some of the first Black Friday events, we had these first like tens of thousands of concurrent users, large parallel compute. We were running networks of thousands of servers, multiple countries, multiple continents. And the cloud was really starting to become a thing due to this. Like everybody wanted scalability, but big data was also emerging. So there was this massive need to make everything more efficient. So to do kind of very large scale distributed compute, but without the penalty of virtualization. So we created the first bare metal cloud and kind of at the time the highest performance cloud in the world. And we came to the UK to basically like run this as a startup. We spun it off from the parent company. Um, and the product still exists today, by the way. And that was the first startup that we actually did together. And it's also where we first designed hardware. So some of the team members that we were working with back then still work with us today. And Flavio was leading this entire initiative. So he saw that some things just could not be achieved.
Mhm.
So the reasons that some clouds couldn't do what people wanted them to do is just the hardware was not designed that way. So Flavio was like, okay, we need to go to a hardware level and make this possible, and we did. And from there, yes, when I left, I ended up one of my clients brought me into a company called Game Analytics. I became the CEO of that company. Um, Drove it to kind of quite significant growth, had data from over 2 billion players per month, one of the largest data platforms in the world. Brought Flavio on board actually to build and launch one of our products, which was very successful. We launched this market intelligence product, and our first large client was Facebook, and it just became kind of the default for older market intelligence around gaming. So some really cool things that we did together before this. And then Stable Diffusion showed up, and we started Runware. But Flavio, I'll let you talk a bit for your background as well.
Well, before working for this US company, I started three companies. One was one of the largest e-commerce website in Romania, and then the second one was an ad tech company, and then the third one, which is basically the software company from which I spin off these two other startups. Which was acquired, as Ioana mentioned. These two companies were very early in Romania. I was just like a entrepreneur trying to figure out what does it mean to make a business, and I didn't know what an invoice is, what a contract is. Like I was just very, very young. Anyway, going back to what Ioana was saying, when she went to Game Analytics, I remained. Actually, I moved to London and I started an genetics company. Couldn't find product market fit. It was a very interesting experience. I spent all my money, all my friends' money. Like I spent everything that I've been able to get from family and friends and from my previous exits, and I couldn't find product market fit. It was like the first time in my life in which I started the company, I couldn't find product market fit. It was a good experience, and then basically almost went bankrupt. Ioana hired me at Game Analytics, and then we built this product together. And then Ioana left for another company called Homa Games, and then I basically go into trying to understand how Stable Diffusion works, how is it even possible to make images just from a text description. And this is how this project came alive. It was called PicFinder, and it was very similar to Google image search. You just type in a prompt, and then the images were generated in real time. And this was kind of like, it took off very fast. Like in a few months, we were having like 1 million users, and it was just growing. It became very expensive, and that's when we initially raised our first pre-seed, I would say, from Anderson Horowitz Speedrun. So this is basically how we kind of started to work on this business.
Got it. Sorry, I'm like coughing today. But okay, so I guess like I want to start with like, I know that you guys have discovered the problem since like Stable Diffusion kind of like showed up, and maybe we could talk about the interaction between hardware and the training process. Like maybe if you guys can give us like the traditional kind of like way of how people were doing multimodal inference in the past, and like how is like Runware different than like how people were traditional doing it, and why is it have to be combined with the hardware innovation as well?
I can take this at a like kind of principle level, and maybe Flaviu, you can go into the details. But basically, the way everybody still does AI inference is rent a bunch of GPUs, slap some models on there, typically in some containers, and then dedicate those nodes to some model. And then sometimes the load is like 30%, sometimes it's 50%, but it's almost impossible to get like 100% utilization. This is for a number of things. One, you need peak capacity. But two, enterprise hardware is not really designed for AI inference throughput. So just I'll let Flaviu go into that, but basically it's actually extremely hard or almost impossible to get the maximum throughput from a GPU when you are running it in a typical setup. But this is what people do today. This is pretty much what all of our competitors do. And what happens is, basically you are getting a standard performance that becomes the market performance. You have the same unit economics. Everybody has kind of the same servers, the same GPUs, and the same type of data centers and so on. So that makes it impossible both to get the optimal performance from the hardware and to get the best version of the hardware you need. And also at some point you just kind of hit a wall of those are the unit economics. It's what a traditional data center costs to cool and what the space costs to rent, and you cannot really push past that. And with the largest clients, especially, we find that they're very sophisticated and they kind of understand the unit economics, and they are very price sensitive because everybody's fighting for margins in AI. Mm-hmm. So then you just hit at this point where it's kind of a race to the bottom of how much of your, how much volume can you negotiate. But also the discount can never be like, you can rent 10 million GPUs. You're not going to get the 90% discount, because it costs to run these things, the power, the cooling, and so on, the amortization. So we knew that if we wanted to break through this wall of everybody's just going to be fighting for the same margin and the same performance, running the same unit economics, we had to include the hardware component into the optimization effort. It couldn't just be software, because at some point you just max out what software can do. And Flaviu, I think you can talk more about kind of how we actually do this.
Sure. Actually, we look into what are all the absolute minimum components that are needed in order to run inference very, very fast. And we've removed everything that was not needed. This allows us to save a lot of money on the hardware. And then we also design a very, very dense inference pod. We call them inference pods. And these inference pods have 1 megawatt of compute, like 1 megawatt of power that is consumed by the compute. And this allows us to be extremely efficient and a lot cheaper than any other data center. And the time for us to build one of these inference pods is like around 2 weeks end to end. by just 2 people, which is like extremely efficient. We've made everything like Lego. We don't use screws, for example. And like we just make everything like so efficient that allow us to build a data center and deploy it in 2 to 3 weeks anywhere in the world and be able to run compute and run inference closer to the users in a very, very efficient way. And this allows us to be like, it's impossible for any of our competitors to be able to match this, because the price of a normal data center from where everybody are renting these GPUs is like 100 times more expensive than the price that we're paying for our own hardware, because we just buy raw material and then we use some factories to process this raw material into what we need. So this allows us to be extremely, extremely efficient.
For sure. You mentioned example of like you guys you're comparing you guys with like the Lego instead of like screw. Can we talk about like the traditional, how is like the traditional GPU inference has been like built? And like you mentioned about it's like, I guess like cheaper and faster. Like what kind of like how does I guess like in terms of the technology, why is it like a Lego versus like the screw? Like, and then is there any, I wouldn't say downside, but like, you know, I think people were using the traditional GPU for a reason, right? So like, what are the pieces that you feel like could be saving costs, and then what are the pieces that you wouldn't change for?
There are a lot of components in a server which are not needed when you do inference, like a HP, Dell, Supermicro, any standard server provider. They make servers to be universal to multiple type of customers and use cases, and because of this, they contain a lot of components that are not needed when you do inference. These servers is like almost 1 meter long, so they are like very big, and this consume a lot of space, so you cannot be very dense. We've been able to compress our servers to 20 centimeters wide, and this allow us to be extremely, extremely dense. Like we have GPUs near GPU in these inference pods, and we cool them with water. Most of these GPUs, even on B200s or like one of the latest GPUs, they are still, or most of them are still cooled with air. Air doesn't have enough capacity to move heat, and this just the cooling units in a normal data center are bigger than our data center completely. So these are the things that we have to engineer, like designing a different cooling system and a better one, redesigning a server from scratch. Like our servers are not, you cannot buy them from off the shelf, and everything else in our data center is designed by us, other than the NVIDIA chips or like AMD CPUs or like memories or NVMe drives. These are standard, but everything else is designed and built by us.
Are you guys?
Oh yeah, sorry. Just a quick mention. I wanted to mention that we also see this. It's also strange how unusual this is, because people tend to either do just software and like software acceleration, or they tend to go, we design our own chips, and we think both of those is like, one is not enough, one is too much. I mean, for us at least, like designing your own chip is like a multi-year process, extremely hard and so on. But there's an incredible amount of performance to be gained in just curating what you have and putting kind of I'm not talking about getting off the shelf components and off the shelf servers, but just curating boards, components, server design, data center architecture. So going in the middle of these two things and optimizing everything to run inference. So we wouldn't advise anybody to run like databases on our servers. They're made for AI inference. You probably could, but it just is not what they're made for. They're made for AI inference. And you can get a lot more out of this, because you can pick the precise components running at the optimum speed, working together perfectly, the right memory lanes with the right, and so on, to truly get what you need. And we save, like, this both increases our throughput. So like one of our nodes has twice the AI inference throughput compared to like just running even the same components in a regular server. So if you were using the same GPU, same chip, and so on in a regular server, you would get twice as much performance from our nodes. Because of the way that all of the hardware is connected. And two, the extension to the models. So to our model lake is also very important. So we run over 400,000 models right now. Our vision is to run millions of models. And we can load these models in real time from a unified data lake. So the fact that we control the hardware has also allowed us to create different software on top than anybody else has, that enables real-time model loading and offloading into memory. So this means not paying for cold starts, not waiting a long time for models to be deployed, not having dedicated 30 GPUs for this, 40 for this, but more like one unified cloud running any model where you can be incredibly efficient in terms of utilization as well. So you're getting more throughput, you're getting more utilization. All of this is cheaper as well to buy and to run. And then we pass all these savings on to our clients. So this is why it's like when we say it's up to 10 times cheaper, it's because all these things add up. It's not like one single thing that you could do tomorrow that would get you the same result.
I want to add one more thing, which is important. Because we control all this hardware, we could reuse multiple components across generations. Like, to give you a very simple example, power supplies. Every time you buy a new server, HP, Dell, Supermicro, they just force you to buy a new set of power supplies because they are not compatible, and they make them not compatible just to sell you more. And in our case, we are able to use the same power supplies across multiple GPU generations, and this allows us to save a lot of money, like thousands of dollars for every server just in power supplies. And this is like this, all the savings add up, and this is important long term. 12 volts from a power supply is 12 volts no matter what GPU are you using, is the same. If the GPU consumes more power, you can put multiple power supplies in parallel. So but the power supplies are the same.
I wonder, I also want to give hi, oh, pay me, hello. I want to shout out to anyone who comments. I feel like a lot of people are lurking, but not many people want to comment. So I like to encourage people who comment. So I wonder, when it comes to, I guess, like redesigning the chip and the server and everything. So like, I guess like why do you guys feel like people are not doing it right now? So like, what is like blocking everybody right now?
It's very hard. It's extremely hard, and you need to know people to design hardware, mechanical design, cooling. Like, you don't do a cooling at the data center level, you do cooling at the chip level. It's a very different thing. And in the same time, you need to know factories. You need to know from where you buy different chips. When you design your own hardware, you need to buy chips from different providers. Then you go in this area of managing thousands of different components from different factories with different lead times and with different minimum buying, and like all this adds up in a very complex problem. And because we had this experience to do this hardware in previous companies, we knew the factories, the people. We like sometimes just to get access to reference design, how to integrate a specific chip into your design can take a year, right? And then they give you like documentation for like 2,000 pages of documentation that you need to read and to be able to put this chip in a design, and then you make a mistake and then you have to redo the PCB and like write the firmware, and all this stuff can take time. And like you could start to work on this project, and if you make a mistake, you lose like 4-6 months. And like, so people they just prefer to buy off-the-shelf hardware because it's easier. Just go on a website and order a GPU.
And I wanted to add, it's also just not just the hardware design, but even just hardware optimization is not a super common skill set. Like most software engineers from the past 10 years have grown up in a cloud first paradigm. Like, I use AWS, I use GCP. Why would you use anything else? So very few people have actually gone to the hardware level to do those optimizations. Those people are usually in like high frequency trading, things like that. So industries that are already kind of made a big difference. But AI is on one hand different, like it's a different type of workload. That's why actually some people from crypto, I think, probably went into AI inference as well. And you see that because that was like, they had to deal with the hardware and they had to do that. But it's basically a rare skill set to even optimize hardware. It's an even rarer skill set to design. So and for us, the first time we did it, it took 4 years. The second time we did it, it took a year. And we have like the inference pods working and so on. But we found it was very challenging to get people to believe that this was possible. So one of the things that we ran across was like, but you're like 20 people. How did you do this? This makes no sense. And we're like, we just know what to do. It's like, it was a bit like, what do you want me to do? It works. It's like, here it is. I can't do anything more than show you that it works. But we found that like people didn't even believe that this was possible when we were first telling them. So it's really great to be here and be like, we're scaling, it's working. We have plans to take this to multiple points of presence all over the world next year.
I wonder, so like I think like in particular in the gaming as well as like the new media space, like I know that you guys have worked with like Hicksville, which is like the Hicksville founders Alex and Mahi were both on our pod before, and like and among other like top companies. And what why Oh my God, I'm sorry. I'm like, I don't know what's going on.
Yeah, I had a cold like for a month, very similar,
Yeah.
like coughing
Oh my
all the
God. It's like, it's not even a cold. It's just legit coughing. I'm like, I don't even know what's going on.
time.
Um,
Legit coughing.
yeah,
It's the
it's,
first time
yeah,
hearing.
my solo coughing episode. But so when you guys are like, since you guys have worked in the gaming space, and then I feel like in the new media space, especially also like maybe even crypto space, or like NFT or a metaverse, like everybody's like generating a lot of like digital image or like pictures or like videos. I feel like that's like a really major use case for GPU. Maybe we could talk about like why is that costing a lot of GPU, and then maybe we could talk about the design that's like specifically since you guys are one API for all AI. Like what are like you guys offer low cost for image, video, audio. Like maybe we could talk about like um how is that different than like traditional like people are training models for, you know, doing SaaS stuff.
So first of all, we work with some of large, like you mentioned Higgsfield. We work closely with them. They're one of the fastest growing clients in the industry. Like their rise is incredible, and they are, for instance, super sophisticated. Like they know what they're doing. They also have in-house setups and so on. They have their own model, um, so they wouldn't. They tend to only pick like the best models, the best vendors, people who are super efficient, and so on. But I remember when we were first doing this, and it was before video, and I was speaking with an investor at like a top fund, like top three global and so on, and not one of our investors, but and they're like, where do you see this going, film industry? And I was like, no, man, TikToks. Like, what do you mean? You know how many films there? You know how many TikToks there are relative to films? You know how many YouTube videos? So basically, that is where the volume is. It's not necessarily of course, polished media is also going to be made with AI, but realistically, what this enables is every person can just make something that was not available to them. And it's a bit like the rise of YouTube, right? And the rise of video in general on the internet. Like the internet has become like 80% video. So this is really what's fueling the growth. Also, I think initially people thought models would get smaller. Again, I remember conversations discussing with investors where like I was trying to say like these pipelines are going to get very complex, and they're like, no, there's going to be on-device models and so on. And there are like both of those use cases exist. But realistically, what we're seeing is in the rise of quality and the need to make consistent characters, like pixel perfect images and videos, models are getting heavier, they're getting larger, and models are absorbing a lot of the discussions with the a lot of the workloads that were previously handled in multiple ways. So, for instance, instead of having control nets and LoRa's, now you just have like Nano Banana 2, which does editing, or you have Flux 2 Dev, or you have Quen. So, you have a mix of open source and closed source models. So, this has, first of all, driven the demand for actual GPU power, like heavier models consume a lot of GPU resources. But also a lot more quality and capability. Like put yourself and a friend in this image. Place your product in this image. Change the background. Do 30 iterations of this. So it's given, for instance, like small businesses, creators, an ability to make incredibly kind of useful production grade content for their ads, for their marketing, for their socials. But it has, as a result, generated a lot of use and a lot of need for compute power. So that's kind of what we see is driving it for us. It's day-to-day internet use that existed before, except now everybody can make production grade studio photography of a product, so that's just fueling people doing more, selling more, making everything more accessible.
I was wondering, speaking of like selling and then all the trends of like people started like making short videos. I totally agree with you guys. Like, I feel like nobody's actually going to the movie anymore. Like, everybody's like producing their own like TikTok series. Maybe we could talk about like, the trends of like, since you guys are powering these like images, like who are you selling to? Since like, and as an end consumer, I don't see myself, purchasing GPU ever, but like obviously I feel like half of the world will do. Maybe we could talk about like, from the generative media perspective, who is a buyer and how does the money flow in the industry that like make you feel like this is a good kind of like
Yeah, so there's AI studios that make it possible for end users to do all this creation. And they have usually the selection of models and editing and frames and text and kind of turning an AI model into an ad creative, into a product photo, into a creator photo, into like a TikTok. We sell to them, to the platforms that enable this for the end users. So our clients do millions of images, videos, and so on. Some of them do hundreds of thousands, some of them do tens of thousands. But the value of working with a provider like us is scale. So if you are doing some meaningful scale, like thousands, tens of thousands, millions, it's worth working with us. We provide all of the models under a unified API. And this is very valuable because there's tens of models in every modality. Something launches all the time. There's a day zero launch every week. In July, we did like 8 launches. Now we do more than one launch a day. So it's really hard to keep up with all of this if you have to integrate multiple providers, pay commitments. Again, if we're open source models, if you want to kind of run your own infrastructure, do GPUs and so on. So we take all of that away. It's like one API, here you go, use any model you want, available on day zero, best price in the industry, and so on. So it reduces the effort of getting access to the models. And then our clients can focus on what is the experience of delivering this model. What products are people building? Are they building stories? Are they building, again, videos, ad creatives? Are they building commerce photos? Are they making commerce photos? So they focus on delivering the best experience for the end user. So that's kind of how we distribute. I have to say, there's also some random use cases we did not expect. So we work with some science centers that like analyze images, or do kind of, I don't know. There's one that I was looking at. One, there's like a research project to recognize types of fish from underwater photos. So there's like all kinds of stuff that honestly we didn't anticipate. That like apparently need a lot more image processing than you would think. But basically, that's who we work with. So for somebody that just needs to do images for their little website, they should work with a Higgs field. They should work with like an OpenArt or an ImagineArt with our clients, basically. Yeah.
Something that I wanted to say, like for a company that it has like a large volume or like a medium volume, it would be more expensive to run the GPUs in house because they will not going to be able to make these GPUs run at 100%. Like they are not able to do the same optimizations. They don't run on the same hardware, and then in the end they will have to pay, buy GPUs, deploy them, have like a 1-year contract, and then the GPUs are not going to be utilized at 100%. And then in the end, and also putting all the people, like all the DevOps and all the MLOps, so like all the time that you spend optimizing a model, and then you run this, and then you have lower performance, higher price. That doesn't make any sense for anybody to just put GPUs, rent GPUs, and put everything into like to build what we build. It doesn't make any sense. So that's why it's a lot easier for people to just integrate our API, pay per image, which is in general a lot cheaper than, as I mentioned, all the other costs associated to putting. And when I say a lot cheaper, like it could, if you do it in house, it could be like 100 times cheaper. We are like 10 times cheaper than our competitors, which already have like super experience. But if you are just somebody who want to put this up, your price is going to be 100 times more expensive.
Yeah. We've also seen really strong technical teams that started with in-house setups and now just want to move. But they're very much like, I would even pay more to just not have to deal with this every day. Like the models change. I have to do new pipelines. I have to do updates. I have to maintain everything. It's a bit like when I could just use an API and used all of that time for something else and get kind of better price performance. So why would I do that? So we are also seeing this, like people who started, and some of them are like super impressive. They did a fantastic job at really optimizing their internal setups, but it's like, this is a lot of work and I just don't need to do this anymore. Right?
I have a question on the comparison between you guys and like, the Together AI or like Nebius. I feel like a lot of these, sorry, I have a cough drops in my mouth, but so when you guys are thinking about like these hyperscalers or like just like I guess neo clouds, like everybody's offering like inference as a service nowadays. Like how do you guys think about like the differentiation? Are you guys tapping into the same market? Because they're both obviously like very well funded and like, from the funding perspective, like obviously you guys are well funded as well, but it's more in like the earlier stage. How do you guys think about like the competitive landscape in general?
What it
Go ahead,
is
Flaviu.
like together, it's our customer actually. So basically, the service that they offer, it's our service. They just offer it through their API, and like Nebius or Voltage Park or all these other providers. Most of their business is coming from renting GPUs. And renting GPU, actually, this is one of the problems. One of the reasons they went into offering LLMs is that these GPUs were staying idle and they just wanted to use them. And they just, started to put LLMs and together, which is, I think, the most complete API right now, like in the world. They offer LLMs and images, videos, audio, and everything that we offer on our platform. So it makes a lot of sense for them to offer this to their customers. And we run all this, like in the case of Together, we run on their GPU. So basically, they use their GPUs, we scale on their GPUs, and all their customers use our technology through their API.
Yeah, and I think we are, on one hand, we would love to scale this. So Together was the first case like this that we've done, where it's like, hey, why don't you sell media models? And when they run, they can run on your GPU. So we get GPUs from you, you get our API, like win-win. And it also helps, by the way, because we own and operate our own infrastructure, but it's always useful to have scale, capacity, redundancy, and so on. So the platform is fully hybrid. We don't need to order like more nodes in order to onboard a new client, right? So those two things are completely independent. It's just, that's how we can run most efficiently. And we do see like more of an appetite for this. But I want to say, I think also the hyperscalers' challenges are somewhat different. So they are competing with each other over who gets the highest volume of GPUs, who gets the B300 from NVIDIA. How many do they have in stock? Are they building data centers? What does it take to run this? Like, they are dealing with hyperscaler problems, which are not, does Qwen image edit run at the best possible performance for a client that does 3 million images? So realistically, it makes sense to partner with somebody who like lives and breathes that, because even if you're super well funded, there's only so many things a company can be amazing at, right? So I think, and we're all like in AI, I think a lot of us are pushing it in that, like, it's probably, I think, the most successful generation of companies ever. The race for talent is insane. The standards are insane. But still, there's only so many things you can excel at. So that's what we see. Like, they focus on a different range of problems, and it makes a lot of sense to partner with somebody like us who can enhance your product offering and run on your hardware as well. So
I was wondering, so like in terms of like scaling, since you guys have raised $50 million, announced it today, congratulations. So how do you guys think about like scaling the production of the whole like chip, GPU, like inference, like, how do you kind of like deploy the capital to make it like scale faster?
No,
you take this one. This is for you. I think.
I think like our goal, as I kind of mentioned this in every discussion, is our goal is to run AI as close as possible to the user. So the way we've designed and think about this inference pod is very opposite to everybody else. Like, they are building very large data centers. They have to get buy land, get permissions, build a data center, get power, get internet, and this takes years and years. And we kind of realized that this is something that will give us more speed, or like will allow us to just have this inference pods closer to the users in a shorter amount of time that will take for them to just set up one single data center. We could have all these data centers, smaller inference pods in every city, in every country. We could put them in a renewable energy park, like a photovoltaic park, or like in a place where we could get cheap energy. And this is very scalable, because we could build these containers, like these inference pods, in parallel, and we could deliver them in the same time across the world. We don't need any permissions. They consume just 1 megawatt. Any street on kind of any city has 1 megawatt of power. Like, we could put them anywhere. They are small. They are like a little bit bigger than a car, but 1 megawatt of power of computing there. So we could have this closer to the users. We could run inference where the need is. And we also believe that in the future, because AI is just going to be part of our life, every country may have a different legislation. They will have different rules, and they will probably want to run these AIs inside the country. So having an inference pod in every city, in every country, will give us a flexibility that no other provider will have. And this is something that we believe is very, very important. And the fact that we could put this in photovoltaic parks, for example, like in renewable energy parks, this allows us to run cheaper than others because we don't have to pay for energy transportation. We don't have to pay for energy conversion from low voltage to high voltage back to low voltage, and all the other taxes. We can just buy energy from the source, which is again allow us to lower the cost, allow us to run these pods better and more efficient than anybody else. And this is very scalable, and this drives the economics and the development time down. We could just put them in 2 weeks, as I mentioned. In 2 weeks we could have a container end to end. We have the shipping time, which could take 1 week or more, depending on where we send the containers, and we could put it in the place connected to the power, and that's it. We could just do this, and we could do 10 in parallel, like 20 in parallel. So the goal for next year for us is to deploy 20 plus inference pods, and then depending on how this works and what challenges we're gonna face, we're gonna decide if in 2 years we're gonna deploy 100 or 1,000. So this is something that we will have to understand.
I have to ask a really niche question, not niche, but I guess technical question. It's not even technical, but what is for 20 inference pods? Is that each company that will get one inference pod, or how does it kind of work?
No, you can. So basically, these are all kind of agnostic, and this is actually built into the architecture. So you could, if one goes down, the others can just handle the workload. They are redundant, so they have redundant power, cooling, and the internet, everything. But basically, let's say one is in Florida and a hurricane hits, it goes completely offline. Yeah, then it's all of the other pods can take the workload. It is possible to also dedicate one. So for instance, if a company went I want this to run in my office, I want nobody else to have access to it, it'd be physically, here it is. There it is. Plug it in. So it is possible to do that as well. It's possible to run them as dedicated workloads. It's also possible to specialize them. So for instance, this one runs LLMs and this one runs images. But right now what we have in mind is a bit of a hybrid approach, which is kind of a set of GPUs that can run the overwhelming majority of models that are agnostic and can run any model. And the way the routing is done should be intelligent, so that you are routing towards a pod the request that makes sense. So Flaviu was describing. So to the pod in California, you're routing all the traffic on all the requests from California for those models. So that's kind of how it is. It's not it's meant to be all unified as one resource pool, but you can also dedicate them to a client.
I love that. So I have another question on this. So one of the keywords that you guys keep mentioning is cooling. Why is it obviously I understand cooling is important. It's you want the machine to function, but how is the traditional thing was designed that why is it not?
Oh, it's because it's so much of the cost actually. So Flaviu, you can talk a bit about the economics, but over the lifetime of a GPU, I think cooling and power usage, but also in power usage, you also usually have cooling. It's one of the largest costs. I think OpEx is almost as large as the CapEx. Do you want to talk through that, Flaviu, a bit?
I could give you some numbers. One of these inference pods, if you collocate the hardware, the equivalent of the hardware in a normal data center, which would be around $80,000 a month, just power, cooling, collocation. And this would be if you think about this is $1 million a year. If you have 300 containers all around the world, this is $300 million a year just in collocating and power. And if you do the way we're doing it right now in a photovoltaic park, our cost is less than $100,000. So we save hundreds of millions of dollars a year just from powering this. Also, you have to think from the perspective of amortization. So if let's say you do the amortization in 3 years, then everything that it's after that, and there are models which you're always going to run on the same GPUs because they are already running in real time. So it doesn't make any sense to just change the GPU if you get real time inference. The cost of running this is just the cost of power. So at some point, the power become 100% of the cost. the power, because power also power the cooling system. So like basically electricity become the 100% of the cost of running a model. So that's why it's like so important to be able to run these models from a source of electricity where it's cheap. As I mentioned, we don't pay for transportation, for all these losses, but also it's I lost my idea, but
that's where cooling comes into play. It changes the power consumption a lot, and it allows us to do this much higher density, which also reduces the co-location cost, and it allows us to kind of air cooling is also reusable and so on. But it's just reduces our OPEX significantly.
Some of the large data centers are consuming a lot of water, for example, to cool down GPUs, because water has more density, and then we spray water on these large chillers, the water evaporates and extract more heat, right? So this is what they do.
Curious, really? They spray water on the machine?
Not on the machine.
No, not on the GPU.
I was like, what?
No. So like they have these large dry coolers, or like cooling units outside, like these large radiators. They spray water on it, and this water just evaporates, extracting heat from these chillers, right?
Yeah.
We don't do that. Like the way we design our cooling system allow us to not consume any liter of water. Like we just fill this up once with water that is running inside the loop, and that's it. And this allows us to also save money on cooling, which is again, like we are based on my knowledge, we are the only cooling system on a data center that use one single loop. Like most of the data center, they have two loops of water. One is happening inside the rack, cooling down the servers, and then there is a heat exchanger, and then it's an external loop which goes from the rack to the outside world. Because we wanted to be more efficient, we just use one single loop. We've removed all the materials that can oxidate, like all our pipe are stainless steel, for example, which in general are used in food industry, so they are not used in a data center. This made the cooling system a little bit more expensive, but also this allows us to have one single loop, and this allows us to remove pumps, heat exchangers, and a lot of systems which are normally in a data center, right? And this allows us to have a more efficient cooling and a cheaper cooling without consuming any water.
So you just learned a lot about cooling systems. You weren't expecting that on this podcast.
I was not expecting that. I was in shock because I wonder like why doesn't like NVIDIA or like anybody else like do this?
I just want to say, I think, again, it really depends on how you think of things. If you were running a data center that also needs to serve healthcare and defense and government, you would probably still want to do a traditional data center, because you would probably you'd get a compliant, like we also do compliance processes and we pass them. But what I mean is like, we're probably not going to be doing like inference for banks to do their financial transactions and stuff, so like, or to do their calculations. So it is still like you have to accept some trade-offs. So we provide AI inference for, let's say, day-to-day internet usage. So this can be like productivity software. So yes, when you're writing a document, you're not kind of like working with secret medical records, you're not doing all of this stuff. So it's perfectly fine for everyday use. But also, if we wanted to sell into like a defense contractor tomorrow, we wouldn't be able to do that, right? And we're absolutely fine with that. There's enough volume on the internet, like I said, for us to grow like a fantastic billion-dollar business. But basically, you do have to think of that for some companies that really want to sell to enterprises, where that is their business model. They do still need to accept some of the traditional limitations, because then that is what these industries still expect. That is kind of how things still run. So we can afford to do this because we're also selling to very future-thinking companies, again, for relatively low sensitivity use cases, but very high volume use cases.
For sure.
I think something that I wanted to add is that, because we are single tenant, like we are our own customer, we don't have to have in our data center 24/7 people, right? Like we like all these things which are in a normal data center, we don't have to do, because like if one GPU goes down, we don't care. Like we can service it once a month. One server goes down, again, we don't care. So we are thinking this data center from a different perspective, where we are the only customer and we are the only one having access to that, and we are the only one to manage that. And I think this is important in every aspect. So when we design the cooling, because this was like the initial discussion was about the cooling and what others are not doing it the same, is that we have the luxury to do things differently because we are the only customer. It's not like our cooling is worse, like it cannot be used by defense. It can be used by anybody. It's just like a different approach. Our data center is smaller, right? We have one chiller, one inference pod. You cannot have one chiller and one row of racks in a normal data center, because this large data center, they try to gain efficiency through other means. But for us, this was it is not like, let's say, the most efficient at actually no, it's the most efficient at the scale that we're doing it for a small inference pod. So that's why I think others are not doing it, because in large data center there are other solutions which are, let's say, more efficient for a large data center.
I wonder, so like maybe we could talk about like on the media side, like what would you say is like the future of media? I know that obviously it is a lot of like these like AI videos pop in, like Hicksville famously, they want to have like 1 in 2 videos is like a AI generated videos. Like, do you guys think that's going to be the future? And then like when people are actually using the API to deploy in their product, whether it's like Wix is your client or like Hicksville, or like all these kind of different like new media companies, like what are some like patterns that you guys have seen? Like, is that like everybody just use like AI generated image, or like what is a trend for people?
So what we're seeing is so first of all, there's, I think, immediate future and what's needed now versus where this is likely to go in 3 years. And what we see that is needed, what is needed now, and people I think really underestimate, is again like better prompt understanding. So sometimes I notice that the models that are perceived as the best quality models have great quality, but they also kind of understand what the user is trying to do, not what they're actually typing. And that makes a big difference. I think that's why Google models are so popular. 2, we see a massive drive for just character consistency. So like if I want the picture with me, I need to look the same in all the pictures, and I need everything to happen. So the increase in quality, it means many things. And this is images. In videos, again, it's like being able to, editing does not really exist in video yet. So you can generate a video and then not able to make small changes, even if you just want one small thing changed, otherwise it's perfect. So that is definitely coming. Longer form videos are definitely coming. So videos have been like 5 to 10 seconds, and we're going to start to see 15, 20, 30 seconds. High resolutions and quality have already landed, but I think we're going to see more of that. The longer the video, the more important editing will become, because if I generated a 3-minute video, I don't want to wait. Like it takes now a minute to generate a 5-second video. So the inference time is 20 times longer. So if you spend like, even if we get that to be efficient, but even if initially you spend 10 minutes generating the video, you don't want to then like generate 5 of them, see the result. You might just want to edit a small part. So in the short term, this increase in quality consists of all these things: better prompt understanding, editing, character consistency, precision in representing brand colors and representing elements in the world, and so on. I think if all these things happen, which frankly will probably all happen next year, then the next stage is kind of real-time generation, right? So we're just generating things as we need them. We're personalizing kind of like real-time ads, if you want, or to the point where everybody sees kind of slightly different content that is just suited to them, because those changes can be made and it's efficient enough to make these changes. So we do think, so as this happens, we think the volume of content will increase a lot. And also the potential to personalize content will increase a lot. But I do think there's this fear around AI content. I do think that what people are looking for is for this content to be like made with AI, kind of in the same sense that it's made with a computer. Like it's just a tool. It doesn't really matter. It still represents you, the real world life. It still looks authentic. So for instance, Sora 2 was super popular because it had this raw look, because it kind of looked in a sense worse than VO, which was super polished, So I think people are still looking for that authenticity, and I think and what we're seeing is that is what sticks, that is what drives the retention. Versus, yes, like fun fantasy cases are still popular, but they are not where the real volume is going. So we expect that like a lot of content will be AI generated, but that it will be made to a professional grade that matches the world, and at the same time, highly personalized and highly real time.
For sure. I wonder, so like, why is there like I guess like uh, I guess like for the API component, so I guess it's I guess like why did you guys decided to I know that you guys are building on the back end, like so how does for example if I'm a Wix or a Hicksville, like how do I engage with uh your I guess like Runware? So like is that like I just use one API and then I'm good? Or like how does it kind of like integrate into their kind of image generation journey?
I'm not sure I understood the question completely.
Same, actually. Can you like
Sorry,
summarize it?
like yeah, because I'm non-technical, so maybe my question is like very dumb. But like I'm just curious about like, when you guys are thinking about like because I know that you like, the tagline for Runware is, the one API for all AI, right? So like is that just like what do I get out of the product? So for example, if I pay X dollar per month, am I just getting one API so that like all my software can just like run on it, or like how does it like actually function?
Oh,
Well,
so I think it would be good to describe two things, Flavio. What would happen if you have a model, like you're a model provider and you're trying to make it available versus how it works for the consumer of the model provider? Like, feel free to take that.
I understood the question a little bit different. I think like for us, one API for all the AI means that we want to provide an API or an interface to any AI model in the world. It can be image, video, or it can be anything else like robotics, for example, right? So it doesn't have to be just images and video and audio or LLMs. It can be any type of intelligence, and we want to build this platform in which any type of intelligence can run very fast, very efficient, and cheap at scale. So this is what we mean when it's like one API for all the AI. Now, API is just an interface between two computers, to services, to pieces of software that can talk together. It's just like a defined language, right? So we provide a defined language in which any application in the world, any service, anything could talk with an AI and ask a question and receive a response, like talk with, let's say, with somebody who's an expert in a certain field. And we believe, I believe a lot into that in the future, most of the products and services are going to be enhanced by AI. And if we have this platform which allow any products and any services to be enhanced by a little bit of intelligence, I think this is something that is very powerful, and it could help the world, move faster or like be better. Or I don't want to go into like large vision, but this is what we understand through one API for all the AI. I'm not sure if I answered your question.
But I also want to add something to that. So what you get as a user when you get the APIs, you can consume, like you can send a call to the API to generate an image or to generate a video. And you will select then what I want the image size to be, what I want the model to be that uses to generate. And then what you pay is you pay for that request. For an open source model, you literally, if you add caching and the inference time is smaller, you will pay less. If you add like these 3 layers of LoRa's that do things, you'll pay a little more because the inference time has increased. For a closed source model, the pricing is usually defined well with the partner, with the model provider. So then it's usually more fixed. It's not quite as variable. So that's what you get. You get the ability to send API calls to any one of these models. If you're a model provider, you can run your model on our infrastructure. You can make it available for other people to do inference calls. And you can set a license price on top. So instead of you running your own infrastructure, doing your model and so on, you can actually just sell it both to our audience or sell it privately if you want and on your own website or whatever. And then you don't have to deal with any of it. We get the model to run, we accelerate it, we do all of that. And again, people just pay when there's an inference.
You're
muted.
Sorry, I have a question on this. So on the website, it says like, for example, 0.1848 per second, and that's saving 26%, or like, some are like per image, some are per second. Like, how does these being priced? And then like what is the saving compared to? Is that like the traditional model, or like, and then why is some of them, like for example, it's the seat dance that's like save 74% versus like, Quinn, yeah, well, that's also 71%, but like there's like, Clean AI that's saving 26%. Like, why is there like a pricing difference for like these different models? Also,
Sure.
Nano Banana is saving the least, and then also it's the most expensive, I feel like, on the website. Like, why?
Like, please send a message to Google. We will take a bigger discount. But basically, with images, it's per image. With videos, it's per video actually. But because sometimes in the industry benchmarks per second, or clients also like to know the price per second, we also show it per second. But you basically pay for the assets that is generated. If it's an audio clip, of like, again, it's also typically audio is more flexible in seconds, so it's typically per audio second. So that's kind of how it's priced.
In general, sorry, I just wanted to say, in general, we try to simplify the pricing model. I saw like pricing to our competitors depending on image resolution, and like an image, like having actually, yeah, like different image resolutions, they have like the same price. Or like in our case, like depending on like if the image is smaller, it's cheaper, right? Because it's just consume less GPU. But we tried to keep the price simple. For images, it's price per image. For video, is price per second. For audio, is price per second. So it's easy to know how much could cost.
Yeah, and I can tell you our API provides the price of everything you generated, like in the response. I can tell you that the pricing is getting a little crazy. So, for instance, Google prices in tokens. Actually, ByteDance for their models, they also price in tokens, but other partners price per megapixel and other. So, actually, having like, if it seems complex, this is like the most simplified version of these models, because believe me, under the hood the pricing is a lot more complicated. It's like a constant struggle to make sure that everything is up to date. A great example for Google is we don't even know the pricing when the model launches, because they price per tokens, and the vertex, like the reporting for Google, actually updates about an hour later. So initially we all launch, the entire sector launches with kind of this temporary, like, this is our best guess of what it will cost, and then when we see the real data, we update the pricing, which is a little crazy, but that's what AI is. Everything is day zero. But that's kind of how it's priced. Yes, and the reason there's differences, it depends on. So we benchmark against competitors. We have a couple of reference competitors, but they usually their pricing tend to be very similar. So
I have another question on this. So, one of the company in the industry, like Fall AI, so I don't know if they call themselves, or it's like the media call them like the Stripe for generative media. What does that mean? So like, why is it Stripe for generative media? Like I feel like it's more of like it is back end, but it's not like you're charging on top of this, right?
well, I think it's more because Stripe took something that was very fragmented and complex and simplified it for people. And I think we all aim to do this. All the API providers in our sector kind of do have this in common. Like provide multiple models, and we're trying to make that simple. So to a certain extent, you could also say that like about us. You could also say that about other competitors. But Fall are like our main reference competitor. Like when we go into a client meeting, if the client's already doing volume, if they're not working in-house, like 9 cases out of 10 they're working with Fal. They're an incredible team. Like they made a lot of impact on the media generation space. They're the first API provider to do high volume video generation across multiple models, and they set a lot of the rhythm for the industry, and they're a very tough competitor, by the way. They do fantastic, and they make us better because
So many good things about your competitor. I love that. I feel like, yeah.
you have to, we yeah, but basically it's because we kind of all try to simplify things under one API and make it available for clients. But usually when we say it's like 70% cheaper, it's often compared to Fall actually. Well, because because they will usually use list price and the provider's list price. So again, it's not just them; it's more an aggregated what the pricing in the market is. but they're one of the most influential price points in the market for sure.
What does a unit economic kind of look like for you guys? Because I feel like when I chat with a lot of founders in the inference or just like in anything related to remotely close to GPU, like everybody's like is paying major dollar to Nvidia. Like then since you guys are designing your own stuff, like I'm sure the margins a lot higher, but like what does that kind of like look like for you guys? And then where would you guys spend the most amount of money on?
Flaviu, I think
From scratch.
Yeah, you take this one.
I think a lot of money still goes to Nvidia because we still use Nvidia chips. So like Nvidia is kind of collecting everybody's AI spending. So
there's no one can like, I mean, I'm sure there's like, AMD or like some other people, but like,
we are already working with AMD to have more GPUs in our clusters. So definitely there are providers which are designing their own chips like Etched, for example, or Grok, and they we are agnostic. Like we don't care. We just want to be the best platform. Like if we can buy chips from whatever provider and we could put them into our hardware, we will do that, and we will run the models which are more efficient on the chips, and we save money, and then we're going to pass all the savings to our customers. So, but right now, majority of the money are just going to Nvidia. So this is a fact.
Love that. I want to be mindful of the time. Maybe we wrap with like one real question and then like 1 minute fire round. So my real question for you guys is like, what is like one piece of insight that you have learned throughout like being at both like, previously it's like data, gaming, now it's GPU and inference, like AI. Like what is one piece of insight that you find like most people do not like, it's like a common thing that like people don't know?
I have two. I have two examples here. One is again that in order to really like if you want to really control your unit economics, you need to control both hardware and software. I think people just don't realize this because they've just not had to deal with it for so long. But I think the second one, which is kind of a cliche, is that truly like your team makes such a big difference. So we like in AI, it's a really like incredible race. We tell people all the time, like this is not like a 9 to 5 job. Like a model will launch in like APAC time zone or PST time zone. We have to have it same day. It has to be like, so if there's a problem, there's a problem. It's all of our problems, and the model will launch tomorrow. So it has to be today. We're fixing this today. There is no tomorrow, and what makes a big difference is really this obvious insight that like if your people are the best people and they have the best attitude, that makes a massive difference to what you can achieve as a company. And I think everybody knows this, but really it's so tested in our field. It is basically how we all run, because otherwise these are like 50 people companies, 40, 30 people companies making tens, hundreds of millions in ARR. It would not be possible if these people were not fantastic. So I think this was always known, but we really see it now more than ever.
Wow, love that. Flaviu, you have anything to add?
I think something that like a mistake that I did in the past was that I was launching something or putting something out when it was perfect or very close to perfection. Now, because everything moves so fast, we don't have this luxury. And unfortunately, sometimes we just have to put something out, and then we go back to the code, and then we do refactor, right? Like next day, like we just release it now, but next day we go back and then we try to make it better and better, right? So it's sometimes you can just revert things. Like instead of making the code better from the beginning, you could put it out, the customer can start to use it, and then you could make the code better and improve it and go back to the mistakes, or like you just understand better how that it's used, what customers are expecting, what error message you should return, and all this stuff, and then you could do another iteration, and then you do just very very small iterations as the product is already out, instead of just trying and doing all perfect before and then putting out. And this allows us to move very very fast. So like we are in a like sometimes we hear there is a model launched by a lab, and then we have it out in 1 or 2 hours on the platform, which means optimization, documentation, website, pricing, billing, testing, and like it's a coordination of an entire team focused on a single model that was just released. And in the same time, there are others that like tomorrow you have another model that it was already announced, or like we have to be very, very agile. It's very hard to plan. We just have to operate as like in a hospital. Like we have to take care of what is important now, and this makes running a business a lot harder than it was in the past. At least for me, I'm not sure how it is in other companies, but to not be able to plan and to execute accordingly to a plan, it's very hard, especially when you have to move very fast and with like a very small team. So this is something that I think is going to be a challenge as we grow to how we keep this.
I wanted to add to that, by the way. It makes you very dependent on people's individual common sense. Like individual people have to make a lot of decisions about how they do things without anybody telling them what to do. You realize how important and how valuable and how rare that is, this ability to make common sense decisions in the moment. And we find that some of the people who succeed the best, like the developers who are most effective, and it's not just that they have the technical skill, they have this like pragmatic, like common sense. What is the right thing to do here? Because nobody's going to tell me what to do.
Yeah. Wow. Like, but how do you make sure that your developer are on the same, like at the same lane? Like, do you guys have like, I guess like also like how do people kind of improve their quote unquote common sense? I feel like it is like very tough, because I think people have like, they could like produce the same result when you gave them enough time. But I feel like you said, like I feel like most of you said, basically it's like it's super agile. Like it's like, at the time that you have to make the decision, I feel like a lot of the timing kind of vibe. So it will just like produce like different results for people.
I think like one solution is to make them responsible. Like, hey, you have to have this model out today, like figure it out, right? And then like when it's the problem is on your plate, then you start to find ways and you start to talk to people, and then you just become more you start to take decisions on your own, and you don't wait for a product manager to tell you what to do, or a project manager, or like you just reach out to people that are important for you to fix whatever you need to fix, or to release whatever you need to release. So I think being responsible, like every team member being responsible for a larger part of the product, I think makes them learn.
I love that. Okay, so I want to be mindful of time. Maybe we'll wrap with a 1-minute fire round for you guys. What's your favorite book?
Favorite book?
So I love. Yeah, go ahead. Sorry.
I think mine was Good to Great. It's like I think I read it like in 20. Actually, I can tell you, it was 2016 when I read it. Good to Great. Jim Collins. It was written by Jim Collins.
For me, it's like Gilead. It's like completely unrelated. It's literature, and it's about the appreciation of slow life in a small in like a small village. And it's called Gilead by Marilyn Robinson. And there's a series of 4, of which I read 3. And it's such a great compliment when you're living in crazy AI times, because it's about a preacher and his family. And there's a quote that really stuck with me that is like, there's 1,000 reasons to live this life, every one of them sufficient, when he's just looking at his kid kind of doing something on the porch, and is getting that moment of just kind of pure human joy. So I like that. I like kind of things that take me completely out of work and out of AI sometimes. Yeah.
Deep. Who would you invite to your dinner party?
RuPaul.
Wait, what?
RuPaul. Yes, RuPaul, the drag queen, the drag queen. But yes, that is it for me.
Yeah,
go ahead, Flaviu.
What was the question?
Who would you invite to your dinner party?
Oh,
I know who it is for Flaviu, actually.
Actually, I think you don't know. I think like my family now. Like I miss my family.
Yeah, I hope the family is listening right now. Who? Wait.
I thought it would be the CEO of Grok, the chip maker. That's what I thought you would say. We both like admire him a lot.
Oh my god, love that. Yesterday I just heard, I think XAI is basically doing Grok too. Is this public?
We're not talking about Grok XAI. We're talking about Grok, the company that is making chips, which are called, the company is called
No,
Grok.
I know. Yeah.
Okay.
I think that what I heard was like yesterday I asked them, what does XAI do? Because I don't know anybody who work at XAI, and then that person knows someone who work at XAI. And they said it is basically Grok. I was in shock because I didn't know. I thought XAI was related to X, the Twitter, but
No, it is, but the Grok is their model arm, and they do have even some image models. I think they're going to put out more models. So actually, for instance, we don't have an integration with Grok today, but we're going to do that. No, they're not. So they are connected to X. They are the AI arm. I think it's run by Elon Musk and something like that. And then there's a chip maker called Grok that
Yeah,
does
that's what
GPU
I
chips
thought. It
similar
was
to NVIDIA or AMD.
they're doing the GPU thing. I thought the XAI was doing GPU thing because
No.
Yeah, I know.
yeah, I know Grok is like kind of like firework AI is like competitor or whatever. Like, okay, I could be
Yeah, they have an LLM, but they also have an image model and so on. So they're like OpenAI or yeah.
Oh wow, okay, love that. Okay, I hope the Grok CEO is listening. Who made the biggest impact in your career?
For me, it's probably Flaviu, actually, because I used to work for him, actually, initially, and then I hired him, and he worked for me, and then he brought me on board to do this startup, which is probably like the most kind of incredible thing I've ever done professionally. So I think for me, it's actually him.
Thank you.
You have to say it's Ioana right now because
you do not. No, you do not.
I think I learned from many people along the years. When I was very young, I was just looking at everybody, and I was just trying to steal a little bit of their behavior, the way they speak, the way they think, the way they interact with others. And I learned from good people and from bad people. I learned what not to do to my team. Like I remember my first job, and one of their managers there just behaved very badly, and I just learned that I should never do that to anybody. So I think it's hard for me. Maybe there is somebody who's just influenced me the most, but I think right now I don't know. I just try to become better and better with every step, and learning from every person in my life.
Wow, deep. Where can we find you guys outside work?
Oh, sleeping.
It's not been a lot of outside of work recently, honestly, and it's not even like it's just not possible. Yeah, but we both live like kind of both in London and in SF. Like we travel back and forth. We both live in Northeast London, which is like a great place to live.
Where's North?
Northeast London. So well, this neighborhood is called Walthamstow, and it's kind of like where people go to have babies and go to craft breweries. But it's actually super well connected, and it has like the largest nature reserve in a city in the world is actually here. London is amazing, and it has like museums and so on. So it's like a very kind of both artistic and great place to live. But London is an amazing place. Like I really love the galleries, the theaters, everything. So yeah, it will usually be one of those things like the Royal Academy of Arts, like all of that.
Amazing. Flavio?
I think I am, like my previous startup, the genetics one, which I couldn't find product market fit. I'm still in love with genetics. I think if I would have more time, I would like to study a little bit more. Like I would really like to learn more about genetics. So probably this is what I would do. So I don't necessarily think it's work related, even if it was a startup, but genetics in general, like, is very beautiful. And I would kind of really like to go back at some point and, continue to learn and experiment. And yeah.
Love that. Thank you both for coming on the show today. It was such a master class for inference, GPU, chips, and AI.
Thank you for
having us.
Thank you guys so much. Okay. Also, shout out to Vincent for coming as well. Okay.
Bye.